right, good afternoon, everybody, and welcome to the second track in the technical field. We're going to be talking about operational best practices in terms of operational checklists for the AWS Cloud that AWS has put together. My name is Steve Morad. I'm an enterprise solutions architect with Amazon Web Services. I work out of the Virginia office, and you can see my email address at the bottom. One of the things that our customers appreciate about the AWS platform is that we provide a tremendous amount of flexibility, a lot of different options for them to innovate and for them to find different ways for delivering their solutions and delivering value to their customers and to their business. But at the same time, they've been asking for a set of best practices that they'd like to know. What are other companies doing? What are things that we can do operationally better? How do we judge ourselves to see and to check what we're doing? And so part of what they're wanting to do is to implement a set of they want to implement consistency in terms of how they're implementing their solutions. And as we were looking at different operational best practices that we could provide, we thought that it'd be really nice to provide it in the form of a checklist so that customers could go through and check off different practices that they're doing and kind of rate and see how they're doing. But as we were doing that, we realized that there was a very wide range of customers that we have at AWS. We have very, very small customers, startups that are in all industries, from social media, gaming, biotech, all across the board, as well as really, really large companies. Multinational companies like Shell that are doing tremendous mission-critical stuff on us, as well as, I would say, almost interplanetary companies like NASA Jet Propulsion Laboratory that actually uses AWS to manage the rovers that are on Mars, which is really, really cool. But we've got that very wide range of companies that are using our platform. Additionally, we have a wide range of maturity of companies. Some that are just starting out their first proof of concept, they're dipping the toe in the water, maybe they're deploying their first application on the cloud. And then we've got other companies that are building very, very sophisticated multi-application deployments on our platform. So we're trying to figure out what's the best way to meet these various needs. So the approach we decided to take was to create two different checklists. The first checklist was just a basic operations checklist. It's designed for companies that are just dipping their toe into the cloud water, and it provides that they can use for initial deployment, prior to their initial deployment of an application, to assess their application's use of specific services, and to help avoid common mistakes that might not be implementation mistakes for things that might not be quite as obvious to brand new users to the platform. The second checklist is an enterprise operations checklist. The purpose of this checklist is to provide a way of identifying some really key concepts to help companies develop a holistic cloud strategy as they're trying to and preparing to develop and deploy sophisticated cloud migrations or deployments on top of the AWS platform. So for the rest of this session, we're going to be here's the basic agenda. I'm going to go over the basic operations checklist. Rather than going off each checklist item one by one, I'm going to group them into related items and talk about each of the concepts behind it. I'm going to talk as well about the enterprise operations checklist to give you an understanding of the breadth of the information that's in that area and the different things that you'd want to think about. Then I'm going to bring Tom from Monetate up to talk about how they have been developing best practices for operating on the AWS cloud over the past 4 years. They're actually kind of a pioneer of a lot of these best practices as well because they've been on the platform for so long. All of this information is available on the white paper section of our website. If you go to aws.amazon.com/whitepapers and do a search for checklists or operational checklists, you can download this checklist white paper yourself, and you can go through and see all the different information. I'm not going to have time to cover everything that's in there, and there are also a lot of additional links to other information, as well as a bunch of other sessions throughout today, both in the technical track and in the other ones, that will go into a lot more detail around things like high availability and disaster recovery and things like that. All right, so the basic operations checklist. First of all, as you've heard in the keynote today, security is incredibly important to us. We know it's very important to you. And so we wanted to make sure that our customers are deploying their first initial apps and that they're looking at us and thinking through the security implications and the security things that they need to be thinking about. As many of you know, deploying on AWS, we have a shared responsibility model, where AWS is responsible for the dirt through the hypervisor. So we're responsible for the data centers, we're responsible for the power, the network, the cages, the concrete, all those type of things for physically protecting the resources, as well as running the services and the underlying hypervisor that runs the virtual machines that you run. The customer is responsible then for the operating system, the application, their data, and securing all of that. So if the basic security questions cover those to make sure that you're starting to understand the different security aspects that you want to make sure have been covered for your application. So the first thing is to make sure that customers are leveraging our identity and access management service so that you're providing individual AWS accounts to your end users. It's a good security practice in any environment to make sure you're not using shared accounts. And we have questions to make sure that you're leveraging AWS IAM users. Secondly, we want to make sure you're thinking through your responsibility in terms of securing your instances. So have you patched your instances? Have you hardened your instances? How are you managing access control to those instances? And again, not using shared access, but providing unique individual access for your administrators to the operating system as well as to your applications itself. Third, AWS provides a hypervisor-level firewall called security groups, which allows you to create very, very secure communication between your instances. You can nest security groups that allow you to create very, very secure hierarchical traffic patterns that force traffic to go through certain instances and don't allow instances to talk to each other. So you can create very traditional hierarchical secure environments with security groups. And we want to make sure that you're doing that. You're thinking through how you're using your security groups and that you're deploying them in a secure manner. Another very powerful aspect of the platform is the ability to share virtual appliances or virtual machines, Amazon machine images, with other customers, or with other groups within your own organization. We want to make sure you're doing that in a secure way. So if you do choose to share your machine images as virtual appliance with other customers, we want to make sure that you've thought through the fact that you need to remove all of your sensitive data that's on the instances, as well as any credentials that you might have put on it as well. So you make sure that you sanitize and you go through the best practices of securing those instances. The next set of questions have to deal with the operational use of Amazon EC2. The first operational aspect is to realize that there are two different instance types that Amazon provides based on the storage of your operating system and your application configuration. The first one is a relatively new offering that's offered in 2009, so not as new now, but newer than the Instance Store. And it's what customers typically think of when they think of virtual machines. So these are your virtual machines that you configure. You can stop them, you can start them, you can move them to another hypervisor, to a different piece of physical hardware, and all your configuration changes that you've made get retained. Instance Store-backed instances are much more ephemeral. It lets you start thinking of compute in terms of very, very ephemeral or temporary compute needs of your instances. So typically this would be, you'd spin up instance-backed store instance if you wanted to grab data from one source, do a bunch of computational processing on it, and then save it out to another source, such as in Hadoop clusters. Or if you've got a huge farm of servers that all share common content from a content management system like a big web farm. So you don't want to pay for the storage that's associated with all of the operating system instances. The big difference is where the data is stored. So in an EBS-backed instance, your operating system and all of your configuration is stored in our Elastic Block Store service, which is a network-based block store or virtual disk technology, versus Instance Store, where your operating system is stored on a physical disk that's attached to the hypervisor. So it's local, so you can't move those directly from one piece of physical hardware to another. So we want to make sure that you're aware, first and foremost, that these instance types exist, and that you think through when you would want to use each one, because there are very valid use cases for each type of them. But if you're not thinking through where you're storing your data and how you're storing your data, it can be, you can get yourself into some trouble. Additionally, in any environment as well, it's important to separate your operating system data from your application or from your application data as well, especially in high data performant applications like database servers. So we have some questions to just make sure that you've thought through how you're separating your data, where you're storing your data, and how you're securing your data, and making sure that you're separating it appropriately. And then finally, a number of Amazon Web Services provide, within the EC2 environment, in order to provide you with this dynamic environment that Janesh was talking about with cost optimization options, with auto-scaling and elasticity to grow and shrink, we provide dynamic addressing so that when your instances come up, you don't have to worry about what IP address it's going to get. So when we're providing these dynamic IP addresses to you, it allows you to be much more dynamic and to scale much more quickly, both up and down. But sometimes for some of our special new users, it takes a little getting used to. And so there are a number of different technologies and best practices that our customers use to address the dynamic nature of the platform, including using load balancers, integrating with a dynamic DNS service so that you always use the same name even though the IP address changes, using our elastic IP addresses, or managing your own addresses like many customers are used to in their own data center by using our virtual private cloud offering and being able to manage your own address space and even provide static IP addresses. And a little later today, there's going to be a session on VPC where you can learn a lot more about how to leverage that in VPC as well as a bunch of other security features. High availability backup and recovery is also very, very important. So we want to make sure that our customers are thinking through how they're backing up their data, that they understand the replication strategy that Amazon has, and that it's important to back up your data. And we provide a number of different options, including EBS snapshots that allow you to take a point-in-time snapshot of your data and then restore it again to additional volumes. You can also use your traditional backup and recovery tools that you're used to using, and you can use those as well. But it's important that you think through how you are going to handle backup and recovery and the availability of your applications. And that also includes thinking about running the critical components of your application or your critical applications across multiple availability zones within a region, and thinking through how am I going to recover this application if I need to. And it's important to not just architect for availability and take backups, but to actually test it and make sure that you're testing your high availability backup and recovery strategies to make sure that they're going to be as effective for you as they need to be. We have some questions that deal with mapping your custom names to AWS Web Services. So a number of the web services that we provide for you automatically scale on your behalf. And in order to automatically scale to the load that you need them to have, the underlying hosts and IP addresses will change over time. And so it's important that our customers understand that and that they use different techniques, either using our Route 53 service to connect to map through alias records to your elastic load balancers, or to use CNAMEs within DNS for mapping your own names to our services so that even if the underlying IP addresses changes, you definitely don't want to use DNS A records. And if anybody has any questions about the differences between different ways of mapping, the resources are available online, but you can also talk with me after or go up to the lounge, talk with another solutions architect, and we can talk you through and make sure that you understand the different ways that you want to map to those resources in order to leverage the full capabilities and power behind it. And then the final set of questions that we have in the basic operations checklist is around application deployment and testing opportunities that you have in the cloud. AWS provides tremendous opportunities and flexibility for you to do additional testing because it's only paying for what you use. You don't have to buy a whole bunch of extra testing hardware and have it sitting around basically being idle for long periods of time. What you can do is you can do parallel testing. You can, using our low cost, you can spin up as additional testing environments, and you can do like performance testing. So you can spin up an environment that's identical to your performance environment, to your production environment, bang away at it for an hour or two, and then return the capacity back to AWS, and you only paid for the couple of hours that you actually used. It's incredibly powerful. It's quick and it's easy, and we hope that you'll leverage this technology to build better, more reliable, better tested environments. In fact, not only can you do like testing, but now you can actually start doing 5 times testing. You can start asking yourself, well, what if, doing what if scenarios. What if I had a 10% growth? What if I had 100% growth? What if it was 1,000% growth? And again, you're only you're spinning up the resources that you need just to perform those tests, just to perform that testing, and then you can return it back to us at no additional cost. So that's the basic operations checklist, again, for companies or customers that are just getting used to it, or even if you have been deploying it and you want to say, hey, I just want to go over this quick checklist and make sure that I have thought through the different use of these specific services. The enterprise operations checklist helps you think through these high-level concepts that we're going to talk about for a couple minutes, it's intended for helping you think through strategically how you want to deploy and develop sophisticated critical applications on the platform. So the first item has to do with billing and account management. So the main question here is whether or not you as an organization have really thought through what your approach is going to be for billing and dealing with multiple AWS accounts. So there are a number of different issues and different things that customers do around our platform. Some of them have to do with how you're going to manage multiple accounts. So many customers use multiple accounts within AWS for different reasons, either to provide an additional level of security granularity between things like test environments and production environments, or in order to provide an additional level of billing granularity between different customers that they might have. And so you'll run different customer resources within a specific AWS account. But you want to think through how you're going to do that. You also want to think through how you're going to do billing and chargeback. So many, especially enterprise customers that I talk to, they initially say that they want to kind of do a one-to-one mapping of here's my bill, and I want to just kind of turn around and hand it over to my business unit or to a customer within the company, and just kind of straight through processing of this is what the bill is. And that's definitely something you can do. However, we also recommend thinking through how you can provide more of a billing service internally to your own company, that you can think through cost optimization opportunities across all your lines of business, and how you can then save money for the company overall by leveraging things like reserved instances or spot instances, and tying that into how you actually do price your products or price your services internally for your company. Of course, we have a security and access management section here as well, and this really starts getting into a lot more holistic security and a lot more lifecycle management. So have you thought through how you're going to manage the lifecycle of your users? So it's not just we're moving beyond the fact that it's great that you have individual user accounts for your users, but how are you going to tie in the lifecycle management of these users into your existing processes to make sure that they're appropriately created and terminated? Are you making sure that you're renewing keys and that you're rotating keys on a frequent basis, and you're following security best practices in terms of managing your credentials? Think through how you're going to secure your data. What type of data do you have, and do you need that to be stored on whole disk encryption volumes? Or do you want to use database encryption for protecting that data? Or do you want to use some level of tokenization so that you can actually bring in and remove the personal identifiable information, process that information, and then pull that information back again? Also, what type of access control do you want to use from a network perspective? Do you want to use SSL? When is that appropriate? When do you want to use secure protocols versus not using secure protocols? So making sure that you're thinking through strategically how you're going to do that and what components of your applications need to have those different pieces. Additionally, how are you going to deal with your operating system and application hardening? It's great that you've hardened your first Amazon machine image and that you're ready to deploy for a particular application, but how am I going to holistically deal with that? Am I going to build in my hardening practices into my configuration management system and make sure that I'm building out secure applications? And how am I going to manage patching my fleet from an ongoing perspective? The next item is dealing with asset management. So managing your assets, both inside and outside of your company in the cloud, is very, very important. And we want to make sure that you think through the different options that you have for managing assets. Definitely, you want to tie in your cloud assets into your existing asset management systems, but there's additional information that we provide, such as being able to tag resources so that you can better group and track and understand what assets you're using within the cloud. We also have a tremendous amount of metadata that we provide, both from EC2 instances that tell you about what availability zone you're running in, that tell you placement group information, security group information, just a whole bunch. There's a whole wealth of metadata that we provide around EC2 instances, as well as your S3 objects. And with all of our services, there's a set of metadata that you can get and that you can pull into your existing asset management and tracking systems to better manage all of your assets as a company. Application HA and resilience, you really want to think from a high availability perspective. What are my mission critical applications? What are my internal SLAs around each type of application? And how am I making sure that I'm building my architectures and I'm architecting these applications to run on AWS in a way that will help me meet or exceed those service level objectives? Again, there's a whole session after this one that's going to cover high availability in a lot more detail, and so you want to leverage those resources and leverage the fact that you can have multiple data centers and you can run your application and span multiple availability zones within the cloud. And then related to that, for disaster recovery, you really need to think through what are my recovery time objectives? What are my recovery point objectives? How quickly do I need to recover? Where do I need to recover? Do I have a requirement where I need to recover, regulatory requirement that says my disaster site must be over 100 miles away, so you might want to consider using another AWS region. Or is my disaster recovery within a region having a high availability solution, I'm going to combine those within a single region. So you need to think through which applications need that, which don't. How do I want to build those together? And there's also a disaster recovery session that's going on today as well that you can that specifically deals with the disaster recovery component. Monitoring incident management. So from a monitoring perspective, AWS provides a number of different monitoring tools that you want to take advantage of, like CloudWatch that has a bunch of EC2 metrics, and all of our other services pump metrics into it that allow you to not only monitor the health of your services, but also to alert and alarm based upon based upon the metrics that you put into it. Additionally, we have a simple notification service that you can use to integrate with existing, that you can use to either notify humans through email messages or SMS texts, or you can also use, it to integrate with another system to send emails or HTTP requests to existing incident management systems or monitoring systems to integrate the two of them. And recently this year, we introduced, or at the beginning of this year, we introduced a new EC2 feature that allows you to monitor the health of your instances. It gives you a little bit more visibility into the health of the hypervisor as well as the health of your instances as seen from the AWS perspective. And so you can query those APIs to get a better understanding of the overall health of your EC2 instances. Incident management, you have an opportunity to not only integrate with your existing incident management systems, but to really transform the way you think about dealing with instances. You no longer have to worry about recovering a single physical server to recover your application. And so you can really start moving into more of what I would call a proper definition or a proper implementation of the ITIL principle of incident management versus problem management. So for those of you who aren't ITIL experts, the definition for incident management within ITIL is restoration of service. The primary focus is to restore service to your customers, and then problem management is trying to figure out, okay, what really happened and how do we keep that from happening again? And in previous companies that I worked for, it was very difficult to divorce those two things because the way that you restored service was to determine what the problem was because you had to actually recover that specific server. And I developed this mental picture of being all in a panic and almost having defibrillator paddles over top of a physical server and trying to resurrect the thing because that was our only option. There was nothing else that you could have. Many of our customers are starting to develop a model where when their application fails, they just throw away whatever instance or component of the application is having a problem, and they spin up a whole new one on another piece of server. And often what they'll determine is that for a certain period of time, they're actually willing to just throw them away until there starts becoming a pattern and it becomes regular. And then they can actually isolate those particular components after removing it from the user. So that, again, they restore service to their users by using brand new, well-known, good configurations of their applications, and then they can now take the troubling component off to the side, and they can start trying to figure out what was going wrong, and then introduce the changes and fixes to their application after the fact, which ties into the configuration and change management opportunities that you have on the platform. You can definitely tie into existing change management processes, but one of the things that you've heard a lot in the summit today is about the power that you can get from automation. And by thinking through how you can automate your configuration change management will make it much, much easier for you to implement the elasticity and to automate the elasticity capabilities that are available on the cloud. And so thinking through how you do change management and working on providing higher levels of automation that you might have before. There are two major approaches to change and configuration management. The first one is really kind of the poster child is Netflix, where everything they deploy is a fully tested image. They fully test and vet every single image, and they deploy everything as a complete image package. The converse of that, from an automation perspective, is that you have a more generic image, and then you have configuration management software that you use, and when you bootstrap your instance, you basically tell the instance what type of role you want it to play, and it runs through all the different scripts that you want it to do so that the server can come up as a fully functional member. It's basically a trade-off between image management on one hand and kind of package and script management on the other hand, and typically our customers are somewhere in the middle. What they might do is take all of the things that take a really, really long time to install and install those first. And then they do little bits of personalization to the servers after the fact, so trying to combine kind of the approaches. But there's a whole range of what people can do. And that also ties into release and deployment management. So you've got a lot of opportunities to transform the way that you release and deploy software on the platform, because again, you're not stuck with a physical set of assets that can't change. So you can start implementing so-called zero deployment or zero downtime deployment models, where you spin up additional new versions of your application and you load balance across the application with new users, and you test out different features. And then if it's taking and it's working really well, then you can pull back and stop using and return the instances with the old version. Or for a rollback perspective, you just pull out of your load balancing the new version of the application that's causing trouble. So it gives you a lot of power and flexibility to really work on leveraging continuous integration, testing, deployment, and optimization models within and transform some of your existing processes to be much more flexible and dynamic. So at this point, I'm going to turn the presentation over to Tom Janowski. He's the VP of Engineering at Monotate, and he's going to be talking about a lot of the best practices that they've developed over using the platform for the past 4 years.
Thanks, Steve. As Steve said, I'm the VP of Engineering at Monotate. I've spent about 15 years building web-facing software and teams that build that software. Monotate is we're a 4-year-old company. I've been there since we started in 2008. We're a B2B provider of website content testing and targeting software. The tools that we provide allow our customers to put the right experience in front of their customers at the right time. So for example, one of our customers is QVC. Our tool is targeted at internet marketers. It allows them to put content in the appropriate location on their website. So for example, an email channel marketer may be able to take creative that they've developed and deployed into an email already, create a a set of creatives inside of Monetate and have that creative and have that same message follow their user across the site. And they're able to do this without making any changes to their back-end systems or templating at any time. In terms of size and scale, from the numbers that Comscore reported for Black Friday transactions, 20% of those flowed through a system on Monetate's platform. So in December, we did approximately 3.5 billion page views off of our API. We've been deployed on Amazon Web Services for 4 years now since we started. So this checklist would have been really handy 4 years ago. It's a great resource to have, and it's been an interesting learning experience going through a lot of these things. I think that from the customer side, the things that I would emphasize about this are, number one, keep it simple. The most important decisions in some ways about the architecture and what we built have been the things we've decided not to do. The second thing that I would say in terms of both the checklist and the services is just because it's there, it doesn't mean you have to use it. Most of our infrastructure is built on really the fundamental AWS building blocks, built on EC2, Elastic Block Store, S3, and also Elastic MapReduce, which is a much higher level service, but we can talk more about later. So following this template of keeping things simple, from a account management perspective, we deal with things very, very simply. We have 2 accounts. One of them contains all of our internal activities, development, test, QA, and one of them is for our production environment. In terms of billing and how we handle the costs of this, I had a conversation recently with a friend here in New York, and we were talking about writing software on the East Coast versus writing software on the West Coast. And he had a really interesting observation that we're talking about all the activity, all the startups, all the fantastic consumer-facing startups in New York. And he was saying that it's a lot like Silicon Valley, except we have a revenue model. And so this is really a key point, right? Is figuring out what does it cost you? And this is something that for us, again, started very simple. For a lot of the problems, at least for a lot of our problems, you can get pretty close with the back of the envelope projection in terms of what you're going to do and how much it's going to cost you. We went through this. We go through this every 6 months roughly, and sort of rebuild that model and make sure that the model that we've created maps to our actual operational costs. For us, it turns out we have a really convenient proxy for what those costs turn out to be. Even as we add more features, we scale out across multiple regions, we add more clients of different types. API calls is a really effective proxy for us for what the end platform cost ends up being. So in terms of our pricing and how we do that, volume of traffic and API calls is really the most effective map back to what our actual operational costs are. And having that model and keeping it up to date, updating it on a time basis, so every 6 months, and also whenever we roll out really significant new functionality, helps us make sure that we're staying inside of the box that we've created for ourselves and saying that, yeah, we're still being, we're still being true to the margin that we said we could create here. In terms of cost optimization, we're probably a little different. We don't do, and this is sort of in the perspective of keeping it simple. We don't do an awful lot of the things that were talked about in the last presentation. We do work with reserved instances. We only use spot instances in Elastic MapReduce applications, simply because it's so simple and it really fits that model so well. And we don't do a lot of dynamic scaling on the micro level. We do a lot of scaling on the macro level. I'll talk more about that reason. I'll talk about more about that in particular when we get to the section on incident management. But one of the things it has to do with is A, about performance for our system, but B, also about being able to understand what's going on when things go haywire. So the way that our software works and the way that our software gets deployed is via a small static piece of JavaScript that gets inserted into our client site and runs on every page view. So Because of that, our clients are trusting us with an enormous amount of access to the users on their site. Because of that, in terms of both the business relationship and the contractual relationship, the security of our infrastructure and the data that we hold is very, very important to us. The way that we approach this is, again, back to that controlling principle about keeping it simple. Having a very, very clear understanding of what the ways are to get into this environment, and by default, keeping most of those off. So Steve's example about nested security groups was fantastic, and the thing I would layer on top of that is there's a great mapping here to the tiers of your application, right? So for example, if I take our application and I divide it up, as it seems to be common today, we have our backend system is written primarily in Python, so we have a load balancing tier, we have a web application tier and a memcache tier, we have a database tier. If you think about those elements of your application and we map those onto security groups, if I isolate, for example, the database tier and we run MySQL, there's no reason for anything to be going in or out of the container of that security group that holds those machines that's not on port 3306 and or is SSH, right? That there really is no reason for any of that to be open. So default to closed, keep that mapping really, really simple. All console access for our operations team is via IAM credentials, so everyone has their own distinct auditable login. All of our access to the AWS API actually happens from within that within security groups in AWS itself, and that's all done via secret keys. The only way to get administrative access into the application is via public key SSH. And the only other paths into our resources at AWS are either via the application's API itself on HTTP or HTTPS, or via the control panel application over HTTPS. So even though it's a fairly large application with lots of control points, there's very, very few ways to get sort of in and out of that environment. And controlling access points is a really good way to keep that under control. We're from the security perspective, we're really fortunate. We don't deal with any PCI data, and we don't deal with any personally identifiable information. So we don't have to deal with encrypting data at rest. So we're able to store data unencrypted in databases and in log files. So given that our application runs on every page load of one of our clients' websites, high availability is extremely important to us. The most important service that we provide to our clients is to always be there. So in order to do this, we've built, number one, a very redundant HA architecture, and number two, implemented something Steve was talking about, which is no downtime rollout. So we don't take downtime for software upgrades. We don't take any scheduled outages at all. So if we think about it from a top-down perspective, and this is probably a good point to talk about this too, is what I'm describing here, right, is not very simple, despite my adage about keeping things simple. And the reason for that is that we need to also remember from an operations perspective that operations is, and this checklist is not a destination, right? These are not necessarily, they're all things you need to think about before you launch something new, and they're all things you should consider in the context of your current application. Doesn't mean you need to do them all, or that you need to do them all right away. Operations is very much about iteration and about progression. So if I were to talk to you last year, for example, my description of our HA configuration would have been very different, and I'm sure by next year it'll have changed yet again. Where we stand right now is that we, from a top-down perspective, we're deployed in 2 regions and in 2 availability zones in each region. We control the flow of traffic into those regions via DNS and global traffic management, so that for any given request, you're always routed to the closest data center. And that and DNS is also responsible for controlling failover. So we're able to completely fail over an availability zone or an entire region and transfer all traffic to our hot, but not current in that context, other region depending on DNS timeouts, but usually within about 5 minutes. And this is actually something that if we have, for example, problems contained to an availability zone, this is something we use fairly often. It's not uncommon for us to shut down an availability zone and simply route traffic somewhere else. It's a lot easier to solve or diagnose problems somewhere when it's not compounded by lots of traffic. If we take a step down from the DNS level and look at the individual availability zone, the way that we configure software, our software inside an availability zone, is extremely consistent. We call them pods, but it's simply a name for a very consistent arrangement of the software that we use in our stack: load balancers, application servers, Memcache, MySQL, and the services that sit around them. Each one of those zones looks exactly the same. Inside of those zones, and coming back to sort of the being simple but being pragmatic, we do our own load balancing. We have HA proxy running on EC2 instances, each one of those with an elastic IP address, and that's sort of the public face of that pod. All the traffic comes into that HA proxy instance, or we also run Nginx there for SSL termination. All the traffic that comes into that HA proxy instance will then be balanced across an available set of application servers. Any failure of a load balancer is handled internally. We have a hot standby that uses the elastic IP takeover provisions to take over for a failed proxy in less than a minute. Any failure that happens sort of internal to the pod, the failure of an application server, the failure of a cache server, is handled by creating a new instance automatically, replacing that instance in the HA proxy configuration, and routing traffic to it. All of our, from a resilience perspective, all of our databases are on elastic block store volumes, really on stripes of elastic block store volumes, and all of those stripes are snapshotted to S3. So to talk a little bit about monitoring and about incident management, Steve had a really great point that for me was really a change in perspective. Coming from a background where solving the problem meant fixing the problem, one of the mistakes that I made early on was investing too much time and too much effort in trying to figure out what was wrong with a particular instance. There are times that you will see erratic network behavior. You'll see spikes in CPU. You'll just see strange things happen. The shift that has taken place is from an operations perspective, from an engineering perspective. Most of the time, that's no longer our problem to solve. We have one of the guys on our team put a great name on it. We do see CPU spikes. You'll see network spikes, and his rule is 3 spikes and you're out. And what that means is that if we see this problem occur, if we see a CPU spike occur, a sustained CPU spike occur over a certain threshold on a certain machine, and that's not a behavior we're seeing anywhere else, we simply kill it. We remove it from the pool, replace it automatically with another machine, and life goes on. And we don't spend any time trying to figure out what it was that went wrong with that particular pool. The other thing that I would mention here that's a little bit of a qualifier on one of the things that Steve talked about is around automation. We do a lot of automation. We're automated in a lot of different places, and a lot of our HA response is automated. But one of the things that we found really valuable and continue to find really valuable at our scale is that there needs for us to be an end to where we automate, and that particularly when it comes to incident response, that a lot of times it's a really good idea for whatever it is that we're responding to stop and to call an adult and have an actual human intervene and look at what's going on in the situation. And a good example of where this sort of things happens is, let's imagine, for example, that we've got 10 application servers and they're using 2 Memcache servers. You may at some point in Amazon Web Services encounter a situation where 3 or 4 of those application servers all of a sudden decide, hey, we can't see that Memcache server, we can't talk to it anymore. But the other application servers can still continue to talk to it. We've seen a net split, right? There's some change in configuration has happened that route is no longer there. This is a great example of where automation can fail you, right? Because the automatic failure there may say, okay, great, well, we're going to go kill that server and create a new one, okay? But that net split might persist, right? The problem and the solution to that problem might not be getting rid of that Memcache instance and replacing it. It might be getting rid of those application servers and replacing them. The short story is, if you automate too much, when things start to go really wrong, and they will at some point go really wrong, you can end up thrashing. You can end up with failure cascading into another failure, cascading into another failure, each one of those triggering some automated response. We found it really helpful for us to put checkpoints in there that, while we've scripted it and we've automated it, requires somebody to look at it and sign off, someone who's on a pager, someone who can respond within 3 or 4 minutes and say, yeah, this is a good idea, and this is the action that we should take in order to fix this problem. So in terms of what sort of things we monitor and how we monitor them, there's really 3 classes of things in our infrastructure that we care about. Number 1 is the CloudWatch level metrics, so the things that we know from the hypervisor. So for example, one of the things we care about a lot on our database tier is idle time on the disks. Okay? As idle time gets really low, that means that we're struggling to write to that disk. We also care very much about system level metrics. So these are things that the hypervisor can't see, but you're inside on the box. So CPU, local disk utilization, all of these system monitoring and performance metrics. We collect those through an old school collect-D style framework. And the third class of things that we care about is application level metrics. These in some way are probably the most important of the bunch, right? Because they really represent your application level performance metrics, really represent the sum of what's going on below those. We take all of those and we roll them up into our own dashboard. We have thresholding for various levels of alerts based on those, and pipe all those out through a great third-party tool that I'll plug called PagerDuty, which is a fantastic operational tool that lets us do great rotations and escalation. So talk a little bit about configuration management and deployment management. Next to the idea of no longer trying to fix a box, this is the biggest thing that's changed in my thinking about how to approach operations since I started at Monetate. The 2 big changes that I've made since in my head, right, since the ways I used to deploy software, is number 1, we never upgrade software on a box. We always create a new instance and route traffic to that instance instead of upgrading the box that was there before. This is made possible by the fact that creating those instances to roll them out, in the grand scheme of things, is really cheap, right? It's cheap in terms of time, we can automate it, and it's relatively cheap in terms of money. What it buys us is that it solves one of those really hard operational problems, right? Is that rollback is really hard, right? If you deploy a new application, you've upgraded the software in place, everyone, if you're good, right, you've written a rollback plan, right? How many people here have gone through to try to exercise a rollback plan and then the rollback fails, right? Yep, exactly, right? Because it's another piece of the system, and it's a thing that could fail, okay? If I don't need to roll back, right, my rollback is to say, okay, stop sending traffic to all these instances and just start sending it back to those old instances that were running this software 30 seconds ago and is still sitting there ready to go. It's a much, much simpler rollback problem than I had before at a relatively low cost. So in terms of how we do configuration management, we have over time drifted closer and closer. Steve talked about the sort of the range of options from we deploy a blank box and do all the configuration there in place, all the way over to the Netflix style of, hey, we're going to bundle it all into an AMI, and the AMI is it. as time has gone on, we've drifted closer and closer to the AMI model. One of those reasons being is that it turns out that it's easier and it's easier to catch problems early in the process. So, for example, if people are making changes, particularly not on the software side, but more on the system and configuration side, where they're introducing new packages, they're installing new software, it is easier for them to duplicate and test that environment if what they're building is a push-button AMI that will end up being exactly the same as what is deployed in production, as opposed to a more generic box that runs a whole bunch of scripts and based on certain conditions does different things. In terms of how we do deployment, I already talked about the rollout mechanism. We deploy code to new instances, we route traffic to new instances, and then over time shut the old instances down. The big thing this gives us in terms of deployment is the ability to do no downtime deployment. So when we roll out new application features from our application side, sort of on the front end side, we practice a continuous deployment model. So we're able to release new features there really whenever they're ready. Sort of on our back end side, we have a 2-week agile process, and we roll releases out every 2 weeks. When those releases go out, we're able to do that, route traffic over, in the case of rollback, route traffic back without taking any customer visible downtime for that. One of the big things for us as an API provider is scale. Steve talked about how AWS makes it possible for us to do testing. And it turns out it's really incredibly simple and it's incredibly valuable. Having gone through this exercise before, in sort of the traditional data center environment, you build some models, you build a spreadsheet, you do some capacity planning, and then you kind of project what you think it's going to be and you hope you're right. Because you typically don't have the budget to go and just buy all those things, put them together, configure them, reconfigure them, figure out you were wrong, that you really didn't need to scale in this tier, you needed to scale in this tier, go back and buy more stuff, and continue the process. What AWS lets us do is effectively do that, right? If you look at, we have a lot of clients in internet retail. Internet retail traffic in late fourth quarter, so between, your traffic between Thanksgiving and the middle of December is, depending on who you are, 5 to 10 times your baseline traffic throughout the rest of the year. If you have to build a platform for that, that's an extraordinary expense. We're able to build and throw away platforms that we scale up, we run 5x, 10x traffic at to see how it scales, and almost invariably the thing that breaks is not the thing that you would expect to break. We're able to tear it down, build a new one in a slightly different configuration, we add more cache, we change the size of the database, we run that with the traffic and observe the results. The other piece that this has given us is that it's also possible to build this into our release process so that we're able to do not just performance testing, but we're also able to do differential replay testing. So I can take, for example, traffic from a particular time period, observe what the results were in terms of the outputs from that particular date of software, and then go ahead and take software that's going to be a new release, run that same inputs against it, and do a differential test against the outputs and say, is the output that I'm getting from this set of stuff going through my API the same thing I expected it to be? And if there are differences, is that expected based on the changes that were in this release of my software? So I'm going to turn it back over to Steve, but I wanted to thank everyone for being here today and thank Amazon for the opportunity to speak.
Yes. So thank you for joining us. I hope that these checklists will help you have a much better and happy cloud experience and help you more consistently implement best practices on the cloud. So thank you.